Okay, problem number 5 on assignment B, April 20th week. We got a little graph of f, just a bunch of lines, and then they give us a function g, that's the integral from 1 to x of f of t dt. Hopefully if you've been doing these problems, you've seen this a few times. One of the big advantages, I think, to doing the problems of these practice problems is you see the same types over and over and over. You get a pretty good idea what's on that test. So the first question was g of 4 and g of negative 2. So g of 4 is just the integral from 1 to 4 of f. G of negative 2 is the integral from 1 to negative 2. They're just area under the curve. So I didn't really show you any work. But from 1 to 4, it's just some triangles. Area is 2.5 from anything underneath is a negative area. And then negative 2, we're going 1 to negative 2. It's all positive area, but it's going backwards, so hence the negative 6. Part B was find the instantaneous rate of change of g with respect to x at x equals 1. Instantaneous rate of change is just derivative, yeah? So instantaneous rate of change is derivative of x equals 1. The derivative of this thing, remember the fundamental theorem of calculus, part 1, the derivative of the integral from 1 to x is just f. So the derivative is f of x. We wanted x equals 1, so it's just f of 1. Come up here, look at the picture. F of 1 is 4. And then part C says find the absolute minimum value of g. So the absolute minimum value of g, I need the derivative. So I took the derivative of g, which I just did up here, remember, which is just f. So the derivative is f, so I want to find out when my derivative is equal to 0. So my derivative is f, which is this. It's equal to 0 right here at 3. And it's positive before 3, it's negative after 3, which means there's actually a maximum point at 3, but not a minimum point. So the minimum point's got to occur at one of the endpoints. You could figure out this in another way, but since we have the two endpoints, we did this up here, right? G of negative 2 is negative 6, G of 4 is 2.5, so the minimum value is at that endpoint. It's negative 6. If that was a minimum point, I'd just have to plug it in, find that area also, and then I'd have that other point. So that's it for problem number 5.